All right, lab safety. Labs are only cool if everyone stays safe. That is just really, that is the basis. And so as I explained in the last lesson, lab safety is about knowing what the risks are, knowing how to limit them, and then knowing how to respond to them. And so the most helpful thing you can have is what's called a material safety data sheet. So all the information that you need can be found in this. It's not always the most concise way of doing it because it has a lot of stuff that's more industrial than you need, but this is material safety data sheet. That's what MSDS stands for. Sometimes just safety data sheet, STS. They come with every chemical you order. They should be kept in a notebook in your storeroom. If you have inherited a storeroom when they don't have these, then as you use chemicals, look them up and print them out and put them in a notebook. If you have time to print out sheets for everything in your storeroom, that'd be great. That would be preferable. But if you don't have time to do that, then every time you use a chemical in a lab or in a demo, look up the material safety data sheet, print it out, put it in a notebook in alphabetical order. That way you can always have it, and it'd be good to also have kind of like an online PDF version of it as well. I have mine, like I said, and I've got key sections highlighted. So material safety data sheets, you pick one up, you'll see something that looks like this. This is the beginning of the first page. They are long. They're usually like 5-6 pages long. This one's 7 pages. This is a common chemical that people like to use. It is a common chemical I do not use because I don't like it. It's dangerous. It does really cool reactions, but it's bad. And I personally made the choice. And once again, I don't want to deal with the risk, and therefore I choose not to. As the teacher, you get to decide what level of risk you want for yourself and what level of risk you want for your students. I don't like the risk that potassium permanganate brings to my lab, so I don't have it. And so it's up to you. So it gives you the name, and these are all by manufacturers. So for example, this was who made it or whatever. So it just gives you some basic information. And then you scroll down into section 2, and this is the hazard identification. And notice this has 4 big hazard diamonds there for you. So we've got, it's an oxidizer, which means it makes things catch on fire. That's what an oxidizing does. An oxidizing agent will take anything that is combustible and you add this to it, it will catch on fire. It's not the worst one out there, but it's a bad one. Okay, acute toxicity. By mouth, skin contact, or breathing in. No thank you. Does a lot of damage if you put it down the drain. So you have to do chemical disposal of this. That is annoying. Therefore, once again, that's another reason why I don't use it. It is a pain to clean up properly. It's corrosive to your skin. It can do eye damage if you're not wearing goggles. Okay. These are all things that, down here. May intensify fire, make it worse. Harmful to swallow, severe skin burns, eye damage. Very toxic in aquatic environments, meaning if you make a solution with it, it's toxic. All right, so these are all things to me that if I start seeing those on a chemical, I'm like, I don't know if I want to use that. Maybe not. But you got to read it, and you need to come in aware of it. Now, hydrochloric acid, for example, is corrosive. Especially in higher concentrations, and you got to be careful with it. You need to know how to respond to it. All right, now we're still in section 2, but now it gives you precautionary statements of how to respond to things. These are important because it's telling you, hey, this is how you respond, and this is what you do. So, if you have questions about it, keep out of reach of children. No kidding at this point in time. Keep away from heat source, sparks, flames, hot surfaces. No burners, no hot plates. Okay? Tie back with clothing. Just basic lab safety at that point in time. If you're going to use it and it's going to be kind of having some dust or fumes, do it underneath the fume hood. Wash after you eat it. Make sure you don't drink in the lab. Basic lab safety. Immediately call poison control. Wash contaminated clothing. If swallowed, you can rinse your mouth, but do not induce vomiting. Okay, some things it'll tell you to induce vomiting, some things it will tell you not to induce vomiting. That's why you need to read these. Okay, this is critical. What do you do if something bad happens? Okay, if you get it on your skin, remove, take off immediately all contaminated clothing, rinse in the shower. For example, I was doing a TA for a lab when I was in high school. I didn't get this on me. It was a potassium dichromate. And basically I spilled some and it got on my shorts. And my teachers were like, go home, take your clothes off, take a shower, and then throw those clothes away. And that's what I did. Because my teacher knew how to respond. And so, I lived 3 minutes away from the school. And so I literally checked out of school, went home, did what I needed to do, and, therefore there wasn't really a safety problem. But you need to read this section in terms of how to respond. All right. In the MSDS sheet, you will generally see this. It will also be listed on the chemical bottles as well, called a fire diamond, and each of them are labeled from 0 to 4. This is the one for potassium permanganate. So red is flammability, so in and of itself it is not flammable. However, it is an oxidizer. It will make things catch on fire and make them burn more rapidly. Blue is health, so on a scale of 0 to 4, it's in the middle. It's not good for you. 3 is physical hazard. That's the corrosive nature of it. It's bad. It's a 3 out of 4. And then white is other things about it that will be on the bottom. So once again, you can look at this, and generally I like to see 1s and 0s for things I use in lab. Every now and then I'll see a 2. Concentrated hydrochloric acid would probably be a 3 or a 4 over here. But like I said, when I see 3s and 4s, I get nervous. And if I can avoid them, I will. Like I mentioned, I'd rather buy a bottle of 6 molar hydrochloric acid than a concentrated one that's at 12 molar. It's half the concentration. If I spill it, it's not I got to get it cleaned up, but it's not as dangerous in that way, and it gives me a little bit more response time, which makes me more comfortable. All right, moving down to section 4, first aid measures. Once again, this is the one that kind of summarizes what we saw in the previous section, but like it says, if swallowed, if eye contact, if skin contact, after inhalation. You need to skim over this. You need to read this. And you need to very likely have this MSDS sheet with you so you can refer to it if you need to in an emergency. If you're not familiar with how to respond, do these. Okay. So once again, when I said in the last lesson, be selective. I don't like having to worry about my students and all of this stuff. So I'm generally going to use chemicals that either A, I know exactly how to respond to, or B, I know aren't going to be that dangerous. When I give my kids 1 molar hydrochloric acid, 1 molar is not really that concentrated. If my kids get it on their skin, they go to the sink and rinse it off. And it may leave a slight red spot if they left it on there too long, but otherwise they're going to be okay. I don't give them things much stronger than that because I don't want to deal with the safety risk. And there are ways to modify those risks. So if you're doing a lab and you're not sure how to minimize these risks and modify them, then I can help you with that. Okay. All right, so the section 6 and 7 have to do with release. So you got to make sure you have it ventilated, and you need to make sure that it's not going down the drains or sewers. So this cannot go down the drain. That's important. Down here, it tells you what it cannot be stored with, and kind of gives you some idea. It says incompatible materials. Though we'll later on in the MSDS sheet, it'll tell you what those are, what you need to keep it away from. Okay. So yeah, here's the incompatible materials in section 10. Keep it away from strong reducing agents. You'll have to look those up. Metals, peroxide, zinc, copper, alcohols, hydrogen, fluoride, acids, and sulfuric acid. So you got to keep it away from those things because it does bad things. And so, once again, these are important things to kind of keep in mind of. So, conditions to avoid. It's incompatible with moisture, heat, and dust. Okay. What if not? Don't store it with these things. How you store things in your lab in your storeroom is important. So Flynn's got a good guide on how to do that in their catalog, but it is something you've got to be aware of. You don't want things reacting in your storeroom when you're not there. All right, and then you need to know how to dispose it. This has to be burned in a chemical incinerator, which means you're going to have to pay somebody to come and get it. So talk to your local environmental, protection agency or, department that you have in your state or your local area, and they can talk to you about how to get rid of things or what companies are good at disposal. All right, some key terms that are important to know. Some of them are obvious, some of them not so much. Flammable, it can catch on fire. Okay. Oxidizer are things that can start or intensify combustion or other reactions. Reactive just means it's reactive with something. Sometimes they'll tell you, sometimes they won't. Remember, like sodium is highly reactive with air and water. Irritant just means it's harm versus contact, as opposed to corrosive, which means it does tissue damage. So like an irritant on your skin will make your skin red, may give you a rash. It can be bad, but corrosive, you're literally damaging skin tissue and possibly underneath the skin tissue. Key thing with corrosive things, you've got to keep your eyewear on, that kind of thing. Environmental hazards mean they're harm to the environment. And then the big three gens: carcinogens cause cancer, mutagens affect genes, and teratogens cause birth defects. So these are things you may see on bottles, you may see on MSDS sheets that you need to be familiar with. Hopefully I'm not scaring you too much at this point in time. All right, chemical bottles. If it's a new bottle from a major chemical company, it should have all the basic safety information on it. But you still want to check your MSDS sheets because it has more detailed information. If the label is hard to read or the bottle is old, you may want to be considering disposing of it. Just because you need to know what your risks are. All right. So this first part of the lab safety lesson we've looked at is you need to know what the risks are. Now we're going to look at how to minimize risk a little bit more. And a lot of that comes down to safety rules. Safety rules need to be a major theme in your classroom. And what do I mean by that is this. At the beginning of the year, I do a lab safety unit. We go over lab safety rules. We go over the lab safety contract. Kids have to get their lab safety contract signed. Once again, Flynn has a good free lab safety contract you can download online and use it. I'll probably attach it to this lesson in the resource section. But those are all things that you got to do. You then, at the beginning of every lab, before every lab and before demos, you need to identify the hazards and tell your students how to respond to them. Every lab I do, no horse playing, no running around, no food or gum. You got to be wearing the right clothing. Hair tied back, that kind of thing. Then you have conversations with them about how they should respond. Hey, if you spill this, like for example, if we're doing acids and bases, we got hydrochloric acid. Like, all right, if you spill the hydrochloric acid on the table, let me know. Do not clean it up on your own. And then other times I'd be like, hey, if you spill that, usually no matter what it is, I tell them, if you spill something, let me know. And I let it be my responsibility to clean up the spill, whether it needs to be paper towels, or if they drop an entire beaker of hydrochloric acid on the table, then I usually have a box of baking soda around whenever we're using acids, and I'll sprinkle the baking soda because that will neutralize the acid, and then I can wipe it up and put it in the trash can. It's pretty simple, but I leave it to me to know how to do it. So I tell them how to respond, which is to let me know. If they break glassware, they let me know, and that's important. You must also communicate with them how to do disposal and cleanup. Hey, these chemicals from this reaction go in this container, these go in this container. Generally, once again, I don't want kids to be in the habit of putting things down the drain. Because sometimes we may do a lab where they can't put it down the drain until I do something with it. So I like to always collect things in waste beakers, which I could have in the fume hood, I could have them on their lab desk, could have them in various places, but I like them to always dump their chemicals into a waste beaker, and then I will dispose of it. Because I want them to be in that habit. Because even if they can flush it down the drain, I don't want them doing that. Because that may be a bad habit for them later. And so in terms of cleanup, I always ask them to get me. In terms of cleanup, I tell them where it needs to go, and then I handle cleanup. I'm trying to limit risk, but I'm also trying to give them good habits. Of, some stuff they spill, it's like no big deal. They can wipe it up and they could wipe it up themselves. But I want them to ask me first. And so I'm trying to get them in that habit. This has to happen between every lab. Every lab you do, you've got to have this conversation. Never assume that the kids remember. Never assume that they know better. It's your job before every single lab to say something. Right? If you feel uncomfortable with a lab, do it as a demo. Bring that risk to you. If you're not comfortable with the kids doing it, don't let them do it. If you are really, really uncomfortable with something, that's usually a good sign that you don't need to do it. Okay? Kind of along those lines, never let kids do a lab you haven't done yourself first. Make sure you run through the lab first. Make sure it works. Make sure what kind of values they should be getting, what it should look like. You need to run through it yourself first. When you set it up, run through it. That's always helpful. That helps with that fear factor coming in. It helps you be more comfortable with it and able to teach it better. But even after that, you're still uncomfortable with it, do it as a demo. And if you're really uncomfortable with it, just do it as a YouTube video. That is just really the simplest thing to do. Okay? So you need to make sure, once again, that you go over lab safety at the beginning of the year, and that lab safety is something you talk about, and it's something you talk about every time you walk in that lab, every time you do a demo. You're telling the kids, hey, you need your you need your safety glasses on, and you need to be back 10 feet. And if some kid comes within that 10 feet while you're doing a demo, you stop. And you make them back up. Because you've got to be strict on this. This is one of those things you have to do. Okay? There are times when I'm doing a demo that I want them to touch something, or I want them to have a safe, closer look. They've got to have their goggles on, and then they can look closer, but they got to do it the way I tell them to do it. If they start going where they're not supposed to going, or touching something they're not supposed to be touching, I'm going to have a fit. Okay? Which reminds me, when kids go in the lab, they need to know they don't touch anything until you tell them to touch it. It's a critical safety rule. And so that's important. So that's just some tips on lab safety. Once again, when you start doing labs, this will become more second nature, and you need to be aware of these things. If you have questions about what something means on a material safety data sheet or on a chemical bottle, you can email, message, office hours, work for that. All right, the last thing we're going to look at is chemical hygiene in the last lesson.